we will solve a problem on column based slab base type design. Okay, and the question is design a slab base for a column ISHB 350 at 661.2 Newton per meter column to carry a factor load of 1000 kilonewton and M25 grade of concrete and Fe 415 steel grade is used for the foundation. So let us begin with the solution. Okay, and the given data is column size they have given us, that is ISHB 350 at 661.2 Newton per meter. Factor load, that is denoted by P of U is equals 1000 kilonewton. Grade of concrete, that is F of CK as 25 M25 and F of E 450, that is grade of steel. Grade of steel. They have given us F of E 450. Okay. Now solution is first we need to calculate the bearing strength of a concrete, and the formula is to calculate the bearing strength of a concrete is 0.45 F of CK. Bearing strength of concrete is equals to 0.45 times of F of CK. Okay, what is 0.45 times of F of CK? That is 25. After calculation, you will get the answer as 11.25 Newton per mm square. Next step, area of base plate. How will you calculate the area of base plate? P of U divided by 0.45 times of F of CK. What is P of U? Is 1000 kilonewton and 0.45 F of CK is 25. Or directly you can substitute the value over here as 11.25. Fine. And after calculating, you will get the value as 88.88 into 10 raised to 3 mm square is nothing but the area of the base plate. Once we have got the area of the base plate, we need to set the dimensions. That is, A is equals to what? A is equals to area, and that is equals to B into L. Okay, so we know this value, that is nothing but A. So let's set a breadth, that is B is equals to A by L. We know A, that is 88.88 into 10 raised to 3 divided by L. L we will take it as 450 mm. L we will take it as 450 mm. Once you substitute, you will get the value of B as 197.51 mm. That we will equate it to 200 mm. That is value of B. Fine. Once we know the value of A and B, we will draw the figure. That is the drawing for your base what we will do? We will calculate the total B, that is from steel table the width of the flanges, that is f of B is equals to 250 mm. Even though it is 200 mm as per this calculation, we can't provide B as 200 mm because as per the steel table, the breadth of this section or the flange breadth is 250. Okay, if it is 250, then now your B will be what? 250 plus 30 plus 30. Why we are providing this 30 mm extra on both the sides? For welding purpose. That is equals 310 mm. Now this 310 will be your B. Fine. Once you know this, then provide base plate of size 450 by 310 mm. Therefore, provided area for base plate, that is equals A1, and 450 into 310 is equals 139.5 into 10 raised to 3 in mm square. Now, third step is to find out actual bearing pressure on concrete. Actual bearing pressure on concrete, that is equals P of U divided by A of 1. What is P of U? Is 1000 into 10 raised to 3 divided by A of 1 is 139.5 into 10 raised to 3. Okay. After calculating this, we will get the value of actual bearing pressure on concrete. That is denoted by W of 7.16 Newton per mm square, and that is the 7.16 Newton per mm square is less than your bearing strength of concrete, that is 11.25 Newton per mm square, and it is okay. Now, fourth step is to find out thickness of base plate. To calculate the thickness of base plate, first we need to find out the value of A and B. So let us find that one. A is equals to 50. Total base plate length is 450 mm and the height of the ISHB is 350. Then do 450 minus 350, we will get 100 mm as a distance and divided by 2. We will get A as 50 mm on either side. So A is equals to 50 mm and B 310, that is total breadth of a plate, minus 250 is the flange width of ISHB 350 divided by 2, that is equals 30 mm. That is equals 30 mm. Now to find out T of S, the formula is, to find out T of S, the formula is 2.5 W into A square minus 0.3 of D square into gamma n naught divided by F of Y, which is greater than T of F, which is greater than T of F. We will substitute all the values in above formula. 2.5, what is W? This value is 7.16, A is 50 square, fine, minus 0.3, what is B? Is also 30 square into gamma n naught is 1.10 divided by F of Y is of 250. After calculating, we will get 13.25 mm, which is greater than T of F, that is thickness of the flange, as 11.6 mm. Hence it is okay. That is T of S. Now adopt, therefore adopt 20 mm thick base plate. 20 mm thick base plate. Now let us move on to calculate the connection. To calculate the connection. Okay. Now we need to provide a connection. We need to provide a connection. That is welding connection. Fine. So this is my ISHB and I need to provide a weld. I need to provide a weld. So, from steel table, from steel table, thickness of flange is of 250 mm. Thickness of weft is of 10.1 mm. And thickness of flange is of 11.6 mm. And height is of 350 mm. Fine. Now we are having the formula to calculate length of weld provided, that is equals, length of weld provided, that is equals 2 times of B of F plus 2 times of D of F minus 2 times of thickness of Y plus H minus 2 times of T of F into 2. It is nothing but what we are doing is 2 times of flange bed is this much, means this plus this. In that what we are adding 2 times of this also, means thickness of web we are reducing it over here. Thickness of this is nothing but web. From here to here we are taking the distance and we are just subtracting the thickness of the bed. So we can get this whole distance for the welding purpose. That's why we are doing this thing. Then length will be how much after substituting the values? That is 2 times thickness of flange, so thickness of breadth of flange plus 2 times breadth of flange minus 2 times thickness of web is of 10.1 plus height is of 350 minus 2 times the thickness of the flange is of 11.6 into 2. So length of weld is equals 1633.4 mm. Therefore provide 6 mm fillet weld. Therefore provide 6 mm fillet weld. Once you provide 6 mm fillet weld, find the total strength of your weld. Total strength of weld is equals stress in weld into area of weld into length of weld. That is equals, what is stresses in weld is 189.7. Area of weld is throat thickness, that is 0.6 into 0.7 into 6 into L of E. Okay, and that is equals 796.74 into L of E. That is total strength of the weld. Once we know the total strength of the weld, total strength of weld is equals to load, that is T of U. Then total strength is 796.74 times of L of E is equals to load is of 1000 kilonewton. Load is of 1000 kilonewton and L of E will be equals 1255.11 mm, which is less than 1633.4 mm. Hence, okay. It means total strength of weld which is required to carry a load, factor load of 1000 kilonewton is 1255.1 mm. But whatever we have provided, the length of the weld as 16.7 1633.4 mm, which is greater than this required. That means the provided length of weld is greater than the required length of weld, and this 1633.4 mm is the length which is provided throughout the ISHB 350 channel. Means this green color, whatever the length I have marked, or you can see I have shaded the portion, that is nothing but the welding, and the length of that welding is of 1633